You sit down to solve a complex problem. The room is quiet, you have the time, you have the intent, and you tell yourself that you are going to focus. Within moments, the tension breaks. An involuntary memory surfaces, an invisible urge creeps in, or your hand instinctually reaches for your phone. It is common to view this sudden break in focus as a lack of willpower. We assume our discipline has failed, or that the problem is simply beyond our reach. A deep thinking functions more like a marathon than a math problem. It is defined by the capacity to sustain attention over a continuous duration. The modern struggle to maintain this endurance suggests that the way our minds operate is being recalibrated by our surroundings. Our digital environment is a landscape of constant interruptions. Notifications, vibrating alerts, and infinite feeds create a stream of fragmented information. This environment functions as a new biological habitat. It demands a specific set of cognitive skills to navigate the volume of data we encounter every hour. When the brain enters a new ecosystem, it attempts to optimize itself for maximum efficiency within that space. Through a process called neuroplasticity, the brain physically rewires its own structure to match the specific demands of its environment. In our current habitat, the most useful skill is the ability to rapidly switch context between different streams of information. Because we practice these quick jumps thousands of times a day, the brain fortifies these rapid switching pathways until they become its primary mode of operation. Our distractibility shows that the brain has successfully adapted to the high-frequency demands of the digital age. This optimization involves a trade-off. Strengthening one neural pathway often happens at the expense of another. This diagram compares two neural routes. On one side, the robust pathways built for rapid context switching. On the other, the connections required for slow, prolonged concentration. The physical infrastructure for endurance thins from disuse as the brain redirects its resources. When you attempt to sit with a single thought, you are using weakened pathways. This creates a physical feeling of resistance and friction. Sustained concentration feels difficult because the brain no longer recognizes it as a necessary survival skill. The current struggle to focus reflects a mind that has aligned its internal hardware with its external surroundings. Because neuroplasticity remains active throughout our lives, the brain can be reshaped again. Rebuilding focus requires deliberate practice. It involves sitting in quiet and leaning into the discomfort of the urge to look away. Repeatedly pushing through this initial friction acts as resistance training. Each moment of sustained attention helps rebuild the biological infrastructure for deep thought. Day by day, the attention span stretches. The brain readapts to a slower pace as it recognizes that concentration is once again required. Our minds remain capable of deep thinking, provided we intentionally carve out the space for them to adapt.